Okay guys, today we're going to talk about how to find slant asymptotes, otherwise known also as oblique asymptotes. So we're going to look at, under what conditions does a graph have slant asymptotes. So we'll kind of be looking at that, and then how do you find them once you figure out that it's going to have one. All right, first, before we get started, though, let's recall what we were talking about horizontal asymptotes in particular. So remember, if a rational function is bottom heavy, that is when the denominator, the degree in the denominator is bigger than the degree of the numerator, when that happens, then we know we have a horizontal asymptote. And we'll call that HA, and that horizontal asymptote is always y equals 0, always, and that's when x approaches either positive or negative infinity. So that's just always going to happen when the denominator is bigger than the numerator, and you let x approach infinity. That denominator becomes so big that it approaches, the whole fraction approaches 0. So like in these three graphs, we see in each one that the denominator degree is bigger than the numerator degree. So, so we've got these horizontal asymptotes at y equals 0. Okay? As a reminder of the vertical asymptotes, those, remember, come from, so the vertical asymptotes.
Hi, Grandma.
Okay, so for the vertical asymptote, VA, remember what we do is we just set the denominator equal to 0. So in this case, it would be x, the denominator, set equal to 0, means the vertical asymptote will be x equals 0. Same here, if you set this denominator equal to 0, you get x equals 0. So that has that vertical asymptote. In this problem, we'd have to factor this, set it equal to 0, positive 2, negative 1, and then the two asymptotes are at x equals negative 2 and x equals 1, right? So, that's how we find the vertical asymptotes. There they are, and then this one is here, that's at negative 2, and the other one's right there at x equals 1. Okay, now we said when the degrees are the same in the denominator and the numerator, then we call that same heaviness. Then what happens is, for the horizontal asymptote, it's always going to be y equals a over b. And remember, this is when x approaches positive or negative infinity. A is the leading coefficient of the numerator, and b is the leading coefficient of the denominator. Okay, so in these two graphs here, we've got the same. This is the first degree, the second degree, and the leading coefficients right here. So this one would be y equals 2 over 2, which is y equals 1. And there's the horizontal asymptote right there at y equals 1. And then same here, the leading coefficients are 1 and 1, which is, of course, y equals 1 again. So right there. Now, remember we said that horizontal asymptotes, that the graph can occasionally cross a horizontal asymptote, never a vertical, but a horizontal. And still, here you do see this piece of the graph is crossing the horizontal asymptote right here, and that's the only place where that's going to happen. So sometimes we do get the graph crossing a horizontal asymptote, but not when, as you get further and further away, as you go left or right, the horizontal asymptote then becomes a true barrier. Okay, so now what happens when the degree of the numerator is bigger than the degree of the denominator? And we said here that there is no horizontal asymptote. There isn't one. Okay? But here's the deal. If the degree of the numerator is bigger by exactly one, then that's when we're going to get a slant asymptote. Slant asymptote. And we will call those SA. Okay? So like in this picture that I'm showing you, I don't know if you can see it, but when we look at the degree here is a 2 and this is a 1. So this numerator degree is 2 and this denominator degree is 1. Notice this is 1 more than, the degree here is 1 more than the degree of this. So here's where we're going to get this, what's called horizontal asymptote, and here it is. Okay? So horizontal asymptote really just means it's, you know, it's not, slant asymptote. It's not horizontal, it's not vertical, it's slanted. In other words, it's line y equals mx plus b, and in this case, I'll show you where this comes from, but that's the equation for that. Okay? All right. Okay, so we're going to work on this problem to see how did this slant asymptote equation come about. Okay, so we're going to take this function and figure out how to find the slant asymptote. All right, so that function is y equals 2x squared minus 3x minus 1 over x minus 2. Okay, so, you know, we know that the vertical asymptote is x equals 2. We also see that this is top-heavy, so there is no horizontal asymptote, but it's top-heavy by exactly 1. So this degree is a second degree and this is a first degree, so that's a difference of 1. So therefore, we do know that there will be a slant asymptote. So that's all the thinking behind that. So how do you find it? Okay, so to find a slant asymptote, and I'll abbreviate SA, we're just going to use long division. We're going to divide this out. So x minus 2 goes into 2x squared minus 3x minus 1. Okay, so hopefully you remember to do long division. Some of you might want to do synthetic division, but that doesn't always work. It only works if the divisor is a first degree. So if the divisor is not a first degree, you have to use long division. So I'm just going to use long division. Okay, so x goes into 2x squared 2x times. Multiplying that out, that's 2x squared, and then 2x times negative 2 is negative 4x. Remember, we are going to subtract. Okay, so this cancels out, and you get negative 3 plus 4 is x, and I bring down the minus 1, and then start all over again. So x goes into x one time, multiply it out, and then subtract. So x minus x is 0, that cancels, and then the negative 1 plus 2 is 1. And so that's the remainder. So we can write it as plus 1 over x minus 2. Okay, so all I did was just divide this, and so what we ended up with was y equals 2x plus 1 plus 1 over x minus 2. Okay, now, remember to find any asymptote, we're going to let x approach either positive or negative infinity. And when that happens, when you let x get really big, then if you plug that into a denominator, the denominator will basically turn into 0. So this just goes away. So what you're left with is y equals 2x plus 1, and that is the slant asymptote. So the slant asymptote is whatever's left from the division when you let x approach infinity, and the remainder just disappears. 2x plus 1, and that's the slant. And then we will talk later about, then how do you graph all this, but we now know that it has the slant asymptote of y equals 2x plus 1, the vertical asymptote is x equals 2, and then, and here's the actual graph of that. So here's that slant, y equals x plus 1, it starts at 1, goes up 2 over 1, and then the vertical asymptote is x equals 2. Okay, and then the branches of the graph are there and there. And we'll work on that later. But for now, I just want you to practice finding the slant, and that's what you'll be doing today in class. Okay? Okay, very good. So give it a try and see what happens.